lesson is solving systems of equation using the elimination method. Today in class we found table method. This is the second way using the elimination method. This is in 5.2, your textbook. It starts on page 197 if you're interested in following along in the book. So x plus y equals 8 and x plus 2y equals 10. Here's two of our linear equations. Elimination means that we are trying to eliminate one of the variables, so it will make the equation easier to solve for the other variable. Eliminating one of the variables. So how do we do that? Step 1, multiply either one or both of the equations by a number that will create a new equation that contain a pair of opposites. For example, x and negative x, or 2y and negative 2y. What can we multiply to have one of our variables cancel out? Well, I think we could multiply this equation by negative 1, and then we would have negative x's. Or I could, and you may do it differently, I could have said, hey, let's multiply this equation by negative 2, and we would have opposites, because we would have negative 2y and positive 2y. Well, I'm going to multiply by negative 1 and get the x's to cancel. So I can eliminate either the x or the y variable. I'm going to use the negative 1. So step 2 says write the new equation or equations and then add them together to eliminate the variable, because you're going to have opposites. And when you add opposites, they cancel. So I chose to multiply this equation by negative 1. So it becomes negative x, negative y equals negative 8. Everything in there becomes its opposite when you multiply by that inverse negative 1. So then the other equation is, it hasn't changed, it's still x plus 2y equals 10. Now when I add these together, yes, my x's cancel, and positive 2y's and negative y gives me a y equals 2. So yes, I solved for the variable. There it is, right there, y equals 2. Step 4, sorry. Substitute your answer into the original equation, to either original equation, to solve for the other variable. Well, this is the easiest equation, x plus y equals 8. Well, I know y is 2, so substituting that 2 in, x plus 2 equals 8. What plus 2 equals 8? Well, x has to equal 6. So I know my variables are, or my solution, state your solution, and check your answers in the original equation. So x equals 6 and y equals 2, or I could write it as the ordered pair 6, 2. That's what I believe the solution is to both equations. You have to check it in both in case you've made some computational error. So here's my first equation, x plus y equals 8. Substituting in, 6 plus 2, does that equal 8? Yes, it does, so that checks. And yes, if you wanted to show it, 8 equals 8, you can keep going. The second equation is x plus 2y equals 10. Well, my x is 6, 2 times my y, which is 2. 6 plus 4 is 10, so it works. You do have to make sure that it checks in both equations. So let's try this one together. 4x plus y equals 9 and 3x minus y equals 5. These are already opposites. So I don't have to multiply either of the equations by something to get one of my variables to cancel. Those will cancel. They are opposites already. So this one's pretty easy. If I add these two together, the y's cancel. So 4x and 3x is 7x equals 14. Well, dividing by 7, I get x equals 2. Substitute that into one of the equations. I'll substitute it into the first one. 4 times 2 plus 1 is y, I know, because that's 8, equals 9. So yes, y equals 1, because 8 plus 1 is 9. So my solution is 2, 1. X equals 2, and you can write it this way as well, y equals 1, or write it as the ordered pair. Now I'm going to check in both equations. So 4x plus y equals 9. 4 times 2, yes, plus 1, I just did that, is 9. That checks. My second equation, 3x minus y equals 5. So 3 times 2 minus 1 does equal 5. So it works. Example 2. 2a plus 3b equals 29, and 2a minus b equals 17. Now I can get my a's to cancel or my b's to cancel. What do I want to do? I think I'm going to get my b's to cancel because I already have a positive 3b and a negative b. I already have opposite signs, so I'm going to multiply this second equation by 3. I could have multiplied one of these equations by -1 and got the a's to cancel. Could have done it that way too. So my equations are 2a plus 3b equals 29, and 6a minus 3b equals 51. So my b's cancel, and I get 8a equals 80. Well, that's not too bad. Dividing by 8, I get a equals 10. Putting that 10 back into one of the equations, I'm going to put it in the second one. 2 times 10 minus b equals 17. Well, that's 20. 20 minus 10, or 20 minus, obviously 20 minus 3 equals 17. So yes, and you could balance the equation if you wanted to, and you get negative b is -3, but I already know 20 take away 3 is 17. So b is 3. Putting those values back into both equations, this is my check. So a equals 10, b equals 3. Or I could say 10, comma 3, the ordered pair, a, b. So 2a, 2 times 2a, well, I'll write it, 2a plus 3b equals 29. Plugging in my values, 2 times 10 plus 3 times 3, 20 plus 9 does equal 29, so it checks. 2a minus b, remember, go back to the original equation, not the one that you created. So 2 times 10 minus 3, 20 minus 3, yes, that is 17. Check, they both work. Next page, example 3. 2x plus 5y equals 11, and 9x plus 2y equals -12. Oh, this one's a little tricky. Now, I think I'm going to get my x's to cancel. 9 and 2, well, I would have to multiply the first equation by, let's say, -9, and the second equation by 2. So I'll have a -18x and a positive 18x. I'm going to get my x's to cancel. So -18x, and continuing with that equation, -9 times positive 5y, would be -45y equals -99. And 18x plus 4y equals -24. Ooh, lots of negatives. So I have -41y's, putting my y's together, equals -123. Dividing by -41, I get y equals 3. Okay, I'm going to put that back into the positive equation. I like that one better. So 2 times x plus 5 times 3, y equals 3, I believe, equals 11. Well, that's 15. Taking away 15, got a little equation solving to do here. I get 2x equals negative 4. So dividing by 2, x equals negative 2. So y equals 3 and x equals negative 2. I'm going to leave those checks. I want you to do both of the checks. Pause the video now and do the checks. Check both equations, x equals negative 2, y equals 3. Pause the video. We'll go over this in class. Example 4. 2x plus 3y equals 7 and x plus 6y equals 8. Well, I think it's easiest if we multiply this equation by negative 2 and get the x's to cancel. So 2x plus 3y equals 7. Negative 2x and negative 12y equals negative 16. So I get negative 9y equals negative 9. Well, y equals 1. And when I put that back into x plus 6 times 1 equals 8, well, that's 6, so x has to equal 2. Well, that was pretty easy. Again, I'm going to leave the checks for you to do, but I'm going to ask you to do one other thing. So x is 2, y is 1. I want you to solve this same example number 4 and eliminate the y's. I eliminated the x's. So I want you to take these two equations and eliminate the y's. So you're going to eliminate the y's. And we'll go over that in class.